So thank you very much for introducing me and for hosting me. I'm not going to talk about the information retrieval part. That's this afternoon, right? Today, it's really the Google culture. And the title here is Google Innovation. I'm not sure you want to hear about innovation per se. I mean, innovation per se is easy. Go invent stuff. Now, people invent lots of crap, right? I mean, you just know this is true. So the innovation part is not hard. So I'm not going to talk too much about that. But I do want to talk about what it means to be innovative and successful, primarily by telling you examples where we didn't succeed. So we learn a lot from our mistakes. And I think, one of the big cultural shifts that Google, I think, is well known for is learning from failure. And we'll talk about some of that. Okay? So what we're doing here is not so much to teach you how to be inspired, because I think that's bogus, but how to evolve a culture, how to hack your culture to provide an environment where you can innovate, where you can be inspired, where you can build stuff, and where you can just also grind stuff out to success. So to frame this, I'm going to start with something I did a few years ago. So before I was at Google, I used to work at Xerox PARC. And just quick question, how many of you know about Xerox PARC? Okay. Anybody? A couple of people. So for the rest of you, I recommend going and reading this book, Dealers of Lightning. Basically, Xerox PARC is a really well-known computer science lab in Palo Alto, California. And we invented a few things there that you might have heard about. The Ethernet, laser printing, bitmap displays. I mean, it's just a bunch of stuff, right? So it's an incredibly innovative place. A lot of those things went on to be successful, like the Ethernet or PostScript, which is popularized by Adobe, but those guys, Geschke and Warnock, were expats from Xerox PARC, and they went off and founded Adobe because it was too slow to do it inside of Xerox. So, which leads to an interesting observation. You can invent a lot of stuff, you can innovate, till the cows come home. How do you succeed? So let me back up even farther. When PARC was in the early days, Alan Kay famously came up with this idea for the Dynabook. And this is his original concept sketch from an early patent app. And it's basically a tablet like yay big, and it's got some keys, and it's got a display. This should look familiar to you. But this was in the middle 80s. Some of you I know weren't here in the middle 80s. That's okay. This is great history at this point. So this was the idea. And when I was at PARC, I joined a few years before this, and I wasn't in Alan's group, but I was in a parallel group. And so we spent a lot of time kicking these ideas around. The Dynabook, what in my group we called a portable document reader. There's a lot of different versions of this. But you notice that no tablets have been made by Xerox. What went wrong? How could you innovate so brilliantly and then drop the ball? That's why you should read that book. Because that book is a big case study about different technologies that were invented there and succeeded and some that failed. This case study is not in that book, which is why I'm telling it to you today. Okay? So the PDR was there, but then in about 1994, I went to Apple. So if you've seen the movie Steve Jobs, this is the entrance to Apple, and that's my office right there. Steve was on the other side. So having worked on these Dynabooks / portable document readers / tablets, whatever you want to call them, at Xerox, I thought, oh man, I need to break out of the constraints of Xerox and go to Apple. And I did that. And then, you can guess what I did there, right? So I ended up leading a bunch of the research that was going on at Apple. And this is one of the things we built. This is 1995. This is a tablet computer. And it was actually a year before we had it like this. Now, this should look familiar to you. It's a little thick. This is actually like, 3 inches thick or something. Weighs about 5 pounds. But multi-touch display, built-in wireless. Ignore those cables. That's stuff we were testing. Speakers and all this stuff. Built-in camera, right? Handle. Oh, well, we'll talk about that. And all these different devices. But this is recognizably probably the first prototype tablet that I know about that actually worked. So the story here is that we did this at Apple. And I remember talking to Steve one day, and say, hey, the future is like this. And he took a look at it, and he's one of these guys who's deeply invested in beauty, design, aesthetics, and all that. Looks at it and says, there is no place in the market for this. What are you talking about? He threw me out. Okay, fine. So I went back to Xerox PARC. And a couple years later, we built this. This is called the uppercase tablet. So this is the first viable tablet I know about. There were a bunch of other tablets in the market around the same time. But this is a direct product of that work that we had done at Xerox earlier and at Apple. So part of the story here is that innovation isn't instantaneous. It takes quite a while for almost any product, even though people like to think, oh, the iPad, it sprung Venus-like from the head of Steve Jobs. No, he rejected the idea in the 90s. But anyway, so we had this thing, and then we had a big product review in late 1999, and Xerox slapped its head and said, what? We don't make computers. What are you talking about? And threw us out of their office. Anyway, they sold that company, lock, stock, and intellectual property, to Microsoft. And Microsoft actually used this as their first tablet computer back in 2000, which was deeply amusing to me. So I didn't do that. At that point, I said, okay, I'm done with tablet computers. I'm going to IBM. And I went to IBM, did a bunch of stuff there. And then in 2005, I came to Google. So, oops, that's what happened. Oh, no. There we go. Just have to restart that. There we go. Moral of the story, don't kick out an HDMI cable. So that's what happened there. So the tablet was really an interesting story because it was initially rejected multiple times. It had a bunch of technology challenges that we just had to grind through. It was too darn heavy back in the late 90s. And so we had to keep figuring out how to do engineering, and there's a lot of stuff about stories about that. One of the big weights here was the display. How do you get the display to weigh less than a pound, which is about, at the time, how much those LCDs were weighing. So it's a major technology challenge. How do we do that? But obviously, we figured that out. So let me tell you a separate story, because the innovation story here is innovation is not instant. It takes a long time. It takes a lot of people. You have to kind of work through these technology challenges, and ultimately you get a device that everybody now recognizes is the quintessence of design, or something, right? So at the same time we were doing that, Ron Abitur was building what's called the graphing calculator. Now Ron's story, because he was circulating around at the same time, is really interesting because it's very similar to this. He was building the graphing calculator, which you now know, if you have a Mac product, you've probably used this, right? You type in an equation, and beautiful rotating shaded graphics, fantastic. Not only was that project canceled, the guys, Ron and his buddy Greg, were laid off, but their badges kept working, so they kept going to work. And Ron told me this story, so I believe him. So they worked on it for another year before they were actually able to sort of secretly slip it into the Golden Master Disc, which went out in 1994. Which is interesting. Super innovative product, because there's nothing like it at the time. Right. Now we think of it as just ordinary. But at the time, it was super novel, very interesting, totally rejected by Apple. Not only were we not going to ship your product, we're going to fire you. Right? But they kept working on it because they believed in it. They were passionate about it. They had that passion, and they managed to get it into every Mac in the universe now. They eventually got rehired. But it's an interesting story, right? What this means, among other things, is that visionaries don't necessarily see the future so clearly, right? They get these decisions wrong. So innovation is often a difficult path that is often led by people with passion. Now, we all know people with passion who are totally crazy, right? You know some, maybe you're sitting next to one, right? Not necessarily, passion and craziness and sanity and insight are not always equatable, but sometimes they look the same, right? So Ron's story is interesting. So one way to think about innovation is that you just forgot all the steps leading up to the thing itself. So Ron and Greg worked on that thing for years and years and years. It comes out in OS 8 or whatever it was. Wow, it's innovative. No, it's not. They've been working on that thing for 5 years, right? Oh, iPad's come out. It's innovative. No, it's not. I've been working on that for a decade, right? So innovation sometimes looks like innovation because you don't know the backstory. And that's true for almost every technology that I've worked on, at Google, at IBM and stuff. It's that we hide the past so effectively that it looks like this flower suddenly springs up after the rains. And the truth is that seed has been germinating for a decade. So that's one thing to remember. So in particular now, at Google, we have this interesting story, which is at Google, we live in a very complex environment. There's all kinds of products that we have, all kinds of services. We have hardware, we have software, we have services, we have cloud, we have whatever. Innovation in a single monoculture that is like a startup or a small group or something like that, that's relatively straightforward. All I have to do is convince you that we've got to ship this product. We're done, right? Here, I got to go convince God and all of his archangels that we have to ship this thing, right? All of a sudden, it becomes very complicated because when you move this piece, it moves 27 other pieces. This is the fundamental theorem of computer science. Nothing stands alone, right? Everything lives on top of a hierarchy of code, of systems, of library, of packages, of services. And when you're in the Google ecosystem, innovation, that is adding a brand new thing, is a little tricky, right? It's not just I can go to Larry Page and say, hey, Larry, great idea. And he'll say, yeah, ship it, right? Oh, he might say ship it, but then it takes another couple of years for me to figure out where all the bits got to be flipped and how I build and so on, right? So as an example, when we bought YouTube, I don't remember how many of you remember this, but it was widely thought that that was the stupidest purchase ever because of like $1 billion or something. Why would you want this when there's other services already out there? So, but we bought it and we ended up, now of course it seems like an almost obvious thing in the universe, right? But at the time it seemed ridiculous. Of course now, people are uploading to YouTube at the rate of 200 hours per minute. We've been talking, 15 minutes? 15 times 200 hours, okay? Think about that. So what does it mean now when you want to do something different in YouTube? Suppose you want to say add 360 video to YouTube. How would you do it? Think about the ecology of things you've got to go change. You've got to go change all kinds of back-end services, all kinds of front-end services, all kinds of search things. So all of a sudden, this one piece of Google, the YouTube piece of Google, has a sufficiently complicated ecosystem that doing something really novel is really hard. There's a huge inertia in these things. And so we think about all other products that we have, like Google Books or Google Videos or Google Earth or whatever, and we have the same kind of problem. For example, what is Google Videos? Wait, it's not the same as YouTube? No, it's not the same as YouTube, right? YouTube is YouTube, and all videos on YouTube are YouTube videos. Duh. Google Videos is the superset. It indexes all of YouTube and all of Vimeo and all of Hulu and all, right? This is a superset. Nobody knows about it. How can you innovate in Google Videos when nobody knows about it? So innovation is also marketing. It's also public awareness. Right? You can have a library that makes the most brilliant innovation of cataloging in all time. If nobody knows about it, did you innovate? If you innovate in the forest and nobody hears it, does it still make a sound? Right? It's an interesting challenge. So let's think about Google Earth here for a second, because Google Earth is what, right? It's a imagery of the entire planet, basically, multiple resolutions. And part of the innovation problem for Google Earth is, how do you steer it? What's the user interface for this? How do you actually make it go from place to place? So if you're here poised eagle-like over Halifax, Nova Scotia, how do you tip the view down? What's the UI idiom for that? I don't know. I really don't, right? So you have to invent stuff. And so what happens is that people try stuff, they try it on their friends, et cetera, you go around and around, and ultimately you get a controller that allows you to tip the view down. But what looks like a simple innovation to you, like I just said, took a lot of time and effort and sweat and testing to figure that out. And what we're trying to do is to match what people's expectations are with what the technology can support, right? Because the technology can support practically anything. But if nobody understands that you need to do a Lagrangian transformation in order to tilt the stupid view up, it's not going to work. So we have to marry what people can do, think, and understand with what's possible technically. And that's a process of innovation. Another case. So this is, I think, a success case. So Google Goggles, right? It's Google image search in your pocket on your phone. Basically, you can go to some place like this. This happens to be Stanford campus near my house. And, well, I'll just show you the video here. So this is me actually standing at that location and then doing a query of reality. This is the innovation here, is I've just launched this app. I then pointed at Hoover Tower there and say, query. Now, here's an interesting thing about this. It takes the picture, and watch what it does. It's scanning like that. This is total time wasting. The scanning doesn't mean anything. It's just to keep you occupied. That's all it's doing, right? But then what it does is actually gives you the information here. It's a landmark. Gives you the website. Fantastic. It's doing search by image. That was a deep, innovative step. Now, technology in the academic world has been around for a while. The interesting problem for Google is to scale it up to internet scale. We've got roughly 1 trillion images. Nobody has tested, at this time, tested search by image technologies before on that many images, right? So figuring out that that was that Hoover Tower and not another tower that looks just like it somewhere else in the universe, that was a pretty good trick. So you see here what's going on is there's a lot of cultural things going on. We have to match user expectation with underlying technology. We have to understand there's a backstory to the innovation paths. A lot of stuff happening here. Now, there's part of innovation that Google deals with, which is bringing technology to the masses, bringing it so it's in your cell phone or on your laptop, right? But there's also a way of thinking about innovation where it's the ecology, it's the ecosystem you're embedded in that changes. So here's a good story. My son is a basketball fan. He loves Stanford basketball. So we would go over to Stanford basketball. And I don't know if you do this here, but at Stanford, I bet you do it here. You go there and people are singing and they're chanting, and it's like this, right? Well, this would be great if I had sound. But if there was sound here, you would hear that chant of oh, 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 like that one, right? The problem is, my son says, how do I search for that? Dad, what do I do? How do I search for that? And I said, let's see. The usual things like Shazam and SoundHound, those are not going to work because it's drunken fans shouting at the top of their lungs. Right? That's part one. Part two, I think, okay, I can do a lyrics search. What are the lyrics? Oh, yeah, right. I know about information retrieval, I know about the mathematics of all this, and I realize there's not enough bits there to actually do anything. So I'm thinking, son, give up. He's a great kid, but he ignored my advice and typed in oh song. Well, he's got it on his iPod now. So what happened, right? How did I, as scientist at Google, fool the system, get it all messed up, right? So what happened was that my son did not know that this was a crazy query. You would not normally think of a repeated term query. So all you people who remember about stop words, A, this is a stop word, B, it's repeated. There's nothing here, right? But we actually index all these things, and we index them in a way that we can then do retrieval. So for example, if you do a search for doobie doobie doo, we actually find Frank Sinatra, right? If you do a search for ooh, 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 you find all the lyrics that are now in question answering sites. I didn't realize there's this interesting, vibrant part of the ecology, these QA sites, where people ask questions like, what's that song you sing at basketball games that goes, oh, 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 oh? And we index all of that. And so retrieval now finds the question and the answer. So the innovation here is nothing we did. Indexing works as indexing does, and crawling works as crawling does, but the ecology changed, the data underlying it changed, right? What's interesting I find about this is that we didn't anticipate this, and I didn't get it until it was shown to me by my punk kid, right? So I was what's called functionally fixated. I thought I knew how Google worked, and I didn't appreciate that the novelty, the innovation here, was that there was all this other stuff going on underneath. And so now it's a strategy. Now the innovation is, of course you search for lyrics, even though they sound crazy, right? And you do that, and you're looking for people with similar questions. So one of the main things I work on at Google is understanding how people do their searches. You do a search. I assume you all use Google. You type something, right? And you get some results back. And what do you see when you get that page back, when you get the search engine result page back? How do you think about it? And a lot of my work is trying to understand how people understand or don't understand the page, what they get, what they not get, and how can we change it to help out. So let me give you an example here. So suppose I do this query, something you might have done. So there's a couple of things here I want to point out that are interesting innovations in the search results page. One of which is we've just done this search, but what's this here? Well, you can search inside of fsu.edu by typing your query in here. So this is an innovation we added a couple years ago, that when you're at a large site with a lot of sub-content, a lot of information architecture, this basically does a site operation search within that site. So this is all new. Right? We have identified the key visited subsections of that site and brought them out as separate items. Okay, so if you're looking for, say, the College of Music, and it's here because a lot of people go there, we just accelerate that process, remove a couple of clicks by bringing it up into here. So the rest of this is kind of what you know. Another big innovation we launched about a year and a half ago is this whole piece right here. Okay, this is called a knowledge panel, and it's basically an aggregation of things we know about FSU. Okay, so this is just the seal, that's the map, et cetera, et cetera. So this is a combination of facts we've scraped from the web and accumulated from other sources on, in the internet. So we've got all this information here. Sometimes it'll get a little bit wrong, like when we pull out the wrong logo. We've seen examples where we actually grabbed another college's logo. Not yours, right? But what was happening here is that we saw that people were going and looking for this kind of information, so we just pulled it up, right? And this happens now. This knowledge panel, right-hand side, appears in a lot of results. Took a lot of time to do that. Probably, I'd say, 2 years of prep work in order to make that happen. And it exists on top of the knowledge graph, which is this vast 1.5 billion node entity graph, which has all this information in it. So the nice thing about it from an innovation perspective is that huge technology, brain the size of a planet, itty bitty little presence on the search results page. And you don't want to know how the technology actually works, right? So that's an opportunity that we took advantage of. But often innovation proceeds by identifying issues, problems that people have. And so one problem I noticed, actually several years ago now, was I was doing a field study. So I go to people's houses, I come to your house, and I watch as you do your search. And so I was interviewing one person, and she was a bus driver, she was looking for information about the DMV code in California. If you've ever visited the DMV site, it's gigantic, many screens full as long. And she was looking for one thing, and she was going line by line by line by line by line, right? And I was ready to gnaw my own leg off. It was just like, is there any other way to find this? No, I'm searching for it. Okay, got it. So what happened is that evening I flew home, and I said to my wife, can you believe I interviewed somebody today who did not know about Control F? And she said, what's Control F? So the basic issue here is how do you find a word on the page, right? So if you do a query like that, you might find the result like that auction catalog, and what your task is, this is a very long page. If all you want to do is find the Reynolds collection on there, you would type Control F or Command F, type Reynolds, and jump to that point. That jump takes you, what, 3-4 seconds, right? Maybe max. So I discovered that there were lots of people who didn't know this. And it just baffled me. Just amazing things. So we did a bunch of studies because that's what I do. I'm a research scientist. I study it. And I came up with this totally amazing result. Doesn't matter. We ran 16 different experiments trying to improve the amount of time it took someone to find a piece of information on a page. Going to the right is worse. Going to the left is better. This is my little experiment. By just spending 30 seconds teaching you how to use Control F, 30 seconds, that's all I need, right? I can improve your performance by roughly 12%, right? I can reduce the time to result by 12%. That's an astonishing figure because people would kill in my business to get 1%. And I can give you a factor of 12 just by teaching you something. And so I thought, wow, that's interesting. So I did some more surveys. I surveyed 2,200 people when I wrote this slide. It was 2,200. It's much bigger now, and it's great. The number never changes. 90% of internet users do not know this skill. That means that at least one of you doesn't know this, right? Statistically speaking, and it's true. When I speak at librarian conferences, I would say, a quarter of those folks don't know this, right? Or worse, half of all U.S. teachers, K-12, don't know this. Half of the teachers teaching our kids don't know how to find text on a page, right? Goes on and on, right? So here's an opportunity, right? We found a problem, an opportunity, so we can start to innovate some solutions. And here was one we had a while ago, automatic highlighter, so it would automatically highlight different colors, different terms in your search string. Okay, that was great. You could actually do it that way, click on that. Or regular expression search. How many of you know what a regular expression is? Okay, awesome, right? So basically what I've done is I've clicked on that little icon right there, is this Chrome extension. And I typed in the expression Apple or Facebook or Google or Microsoft. Show me in the text where those terms appear, and they're all highlighted. So there's Apple, there's Facebook, there's Google, there's Microsoft. Okay? I'm not searching for one thing. I'm searching for, what? 4 different things simultaneously. Okay? So this is text, Boolean, or. Got it? Fantastic. The innovation story here is that we were able, through the mechanism of Chrome extensions, to allow you to invent stuff like this. Not that hard, right? The key idea, though, is that it's possible for anybody to build an extension like that that gives you massive new kinds of capabilities. Pretty straightforward. It's a simple development process. So, what I want to go with this is, let's talk about the culture of Google that allows innovations to happen. I'm going to point these 4 key points, right? You set up a culture where it's just expected. Well, of course you're going to invent new stuff. Of course it's going to be successful, right? Of course we have this expectation of you. The second one is we make it an environment where it's easy. Now, the Chrome extension is one example of that. The current Google build system is not an example of that. It's difficult to launch a whole new product. So when those things are launched, it's a fantastic thing. People had to work really hard. It'd be great if we could figure out how to engineer that. It's an interesting problem. But if you're in a small environment, set it up so it's easy. Third thing, set it up so that you not only can fail and it's okay, but that you learn from that. It is not okay to fail and walk away without having learned something, right? That's part of the cultural expectation. Okay? And lastly, it's great to have an environment where it is okay to be playful. I have worked in environments where it is not okay to decorate your cube. Really? You know? And it's one of these things where it's kind of an ambient sense that you can be playful, you can invent stuff, you can just try stuff out. That's a little bit what the 20% time is about. So Google has this famous idea of 20% time. You basically get a day a week to work on a project of your own choosing. Your manager can't kill it. It's got to be, it can't just be, fly fishing, right? It's got to be somehow relevant to the business. So you're developing, say, regular expression search or something, right? So let's dig into each of these. So expected, right? We have a culture where we ship 5 product launches a week. And in our big weekly meeting, they're all announced. So Larry or Sergey stands in front and says, hey, this week we did X, Y, Z. Okay? That imbues the place with the expectation that you need to ship something. Okay? We understand that the change is constant. I mean, when you have that kind of frequency of updates and changes, it's one of these things, right? Now, there's an interesting challenge here for innovation, which is that you can innovate too fast. You have to strike this balance between what your users, your customers can accommodate and what you can develop. So for example, in 2006, we had this maps tool where the results, you do your query, maps results would appear on the right. So if your query is for pizza, you see there's a dozen pizza places near where I am. Okay? A year later, we shipped it, we moved it on to the left-hand side. That sounds dumb and trivial. It's not. We tested this a lot, and it turns out you move it on the left, it works a lot better. Trust me on that one. We added pictures. Again, we tested it, it works better. One of the key tropes here is we tested it, it works better, because often, I would say probably most of the time, we test stuff, it works worse. Right? One of the things that kills me about universities, and I guess academic settings in general, is that all kinds of stuff gets launched without testing. What? Really? So for example, when I produced my online class, Power Searching with Google, we usability tested the class. When was the last time you usability tested your class? Yeah, occasionally.
Yesterday.
Excellent. But you have to take that result back and change the class as a consequence. Right?
Every semester.
Then you're doing it right. So we constantly do these kinds of things where we're testing, we innovate, we change something, and you can see this long string of changes here. We changed the name of the product, we changed the color, we changed the logo, we changed the layout, we changed all these things. Now, this is all kind of driving towards success by testing constantly and improving the product. Here's a test that we tried. Did not work out so well. One of the key things is, what do you notice about this change in the interface? I'll highlight two of them for you. There's one. This little tiny interactor widget, this one right here, yeah. That little tiny blue triangle, which I can barely see from here, it's that. It's 16 pixels by 16 pixels. Lesson number one, never launch a UI that's 16 pixels on a side. Nobody will see it. Second thing we added is this thing down here. Yeah, this one's 20 pixels on the side, bigger, but it's in the corner. Nobody saw it. Both of these were abject failures. This basically allows you to move the God's eye perspective on the map, and this is a scrolling widget that pulls it out. We now have the same interactor on the maps, except it's 4 times the size. Okay? So one of the things we have to understand to innovate properly is the expectations. What can people see? How can they learn? How can we change their culture? So when you have a map, what is a map exactly? What are the layers you can use? What are the functions people want? What are the functions they can't tell you they want? Right? So we have to think about all these issues. We have to think about, for example, we want to give you alternate routes because maybe, just maybe, I know that this construction thing, yeah, it's only going to add a couple of minutes. This is actually the fastest. No, it's not. I know because I live right there. Right? And so sometimes local knowledge trumps global knowledge. Now, here's another example of an example where we tested some stuff, we developed it, we launched it, and it didn't work out. Instant previews. So observation, we watch you, and we see you going from this page to that page, and back and forth, ping-ponging behavior. Hey, what if we could just give you a preview of the thing before you went to it? Save you a lot of back and forth, right? Definitely true. So this is a prototype. We did a design sprint 2010. So you would click on the link over there, and it would pop up a pre-image of the page and then the selected snippet of the text that's relevant to your search. Right? Great idea, right? Fantastic. So we did this. We kept modifying it. We did various versions of it. So these are all design iterations. 10 more I'm not going to show you. Point is, we did a lot in order to get to this design. It tested well. It was great. So people came in, we launched it, it ran for, I don't know, a year or so. Where is it now? We de-launched it after 6 months. Why? Because nobody used the damn thing. Great idea, solves a real problem, great innovation. If nobody knows about it, you lose. So we unlaunched it, and we incorporated that learning into the warp and weft of what it means to build a search results page. So let me change focus a little bit and talk about Googleplex. So Googleplex is the sort of out there moon launch kind of place, a research group inside of Google. So they're best known for things like the self-driving car, right? So I happen to live about a half a mile from the self-driving car garage, so I see them a lot. You know you're in Silicon Valley when 5 cars pass you as you're biking to work and they're all self-driving. It's a little strange, but okay. But the computational problem here is really interesting because you're trying to actually have superhuman perception. The car has superhuman perception, right? Because this is actually a reconstruction of what the car knows. This is the car. So all this stuff back here, this is all filled in from data sets and all that kind of stuff, right? So here you watch the reality. This is a car with a kayak coming in. It's, if you watch it, well, I'll have to wait for the next loop. Here we go. It's that purple volume right here. You'll see it'll merge in. Anyway, this is all kind of a display. No human sees this. This is just for debugging. This is just so we can understand what's going on. We have also in Googleplex built things like the contact lens that senses the glucose level in your body. Really handy if you're diabetic. No more blood sticks, right? Because you actually read it on your watch. It tells you, oh, okay, good. And it's continuous. Every couple of seconds it tests your glucose. But we had to design it, and so the innovations here are A, having the idea, then B, doing all the technology for that. Because there's a battery and a transmitter and a computer and an antenna all in the contact lens in your eye without hurting, right? Great. But I want to focus on this last one, which you might have heard about, Project Loon. Has anybody heard about Loon before? Okay, come on. It's a great name because it kind of slightly crazy project. The idea is to launch balloons that will then circle the Earth and provide universal Wi-Fi service, right? So all those Wi-Fi systems you got, we're trying to make them all obsolete simultaneously. So the craziness about it is we had this really audacious goal because what we wanted to do was launch enough balloons that the Earth would be constantly covered in them, or rather the Wi-Fi would be constantly covered underneath them, right? So there are a lot of interesting technical challenges. How do you design a balloon that flies at that altitude that will stay up for more than a year? Go ahead, chemies, design me a plastic that will survive at that altitude under that ultraviolet radiation regime, and so on. There's a lot of problems to solve, including steering. Have you ever tried to steer a balloon? Tough. There are ways, but they're tough. But they largely rely on data. Wait, we're really good at data, so we got some way. So we built these things. We did a lot of tests, including giant spherical silver balloons that didn't work. They popped. Giant balloons that looked like pillows, and on and on. We ultimately ended up with just the big bag that you saw there. And we launched the first one in June of 2013 in New Zealand, partly because the southern hemisphere is a lot easier than the northern hemisphere. These are things you have to think about when you're testing products like this. There are a lot more regulatory agencies in the northern hemisphere than the southern hemisphere. Just saying, you know? The good news is that the northern balloons and the southern balloons never mix because they can't get across the equator. So we launched it there, and we had to basically figure out what all the technology would be required to actually get it to work. So that required lots of iteration. Build a balloon, launch it, watch it fall down, figure out how to actually build a parachute that will catch it, because we had a lot of these things fall into the sea. And the water off New Zealand is very cold and deep. So we lost a few. But nevertheless, we fly them way up above, as you can see here, way up above where airline traffic goes. And then you get into these interesting regulatory issues, like suppose you fly over a country that doesn't want Wi-Fi. I know it sounds crazy, but there are lots of countries that don't want this. either because they believe the radiation is going to give them all cancer, or they just don't want public Wi-Fi for whatever reason. So we have to know exactly where we are so we can turn it on and off as you pass over those regions. Right? So all of a sudden, we have to discover by having failures like lawsuits, or failures like balloons exploding, or failures like the chip's not working out, or whatever, right? And we have to pull those all back. And I can't resist, I have to show you this little video because this illustrates the example of the testing regime. This was a booster test, and we have forgotten about these. NASA went through a lot of these, right? A lot of these. I encourage you to go to YouTube sometime and type NASA launch failure. There are hundreds and hundreds and hundreds of these videos. The reason I bring it up is because we have hundreds and hundreds, ours are not as spectacular. I mean, nothing blows up quite like an Atlas 1 booster. But we have a lot of failures, and we have to, when you're thinking about innovation, you have to plan to fail a bunch. Or if you're a VC, and you're trying to fund X number of VC startups, you know going in, 9 out of 10 are going to fail. 9 out of 10 are going to fail. So the value of the VC organization is really they learn all that stuff, right? So they want to get, if they can get to 2 out of 10, that's fantastic, right? They want to learn. They want to be the learning organization that supports that innovation in the form of capital investment in the research world. Okay? So, but moonshots, I think, are a little bit of a funny concept because I hear people saying, well, the reason Google succeeds is because they do all these moonshots. Well, let's talk about moonshot, right? This is the common conception, I think, of moonshot. You start off with an initial investment, and over the course of 3 years, Q1 through 4, up to 3 years later, and you have this huge success. You go to the moon, right? That's not what a moonshot is. You can think about a moonshot, well, let's be less crazy about it. Let's just insist that you have a doubling of content, of value every year. So you start off with some investment, you get 2x, and you get 4x, and so on, right? So you don't quite get a moonshot at the end because this is a factor of 10 improvement, but you get pretty good. You get a factor of 8. That's not bad. But importantly, these are cumulative, right? At the end of the first year, you have something to show. At the end of Q1 and the end of the first year, with the moonshot paradigm, you don't have much to show. But there's a better model. And inside of Google, this is called a roof shot. A moonshot is when you put it all on red 44, right? And you're hoping it's going to work out at the end. You get that factor of 10 payoff. A roof shot is where you have like a 25% or 30% payoff every quarter. You learn something every quarter. Look at that, right? The power of accumulated interest. Again, the area under the curve matters. You're in a much better place at the end of 3 years with a 30% return on investment after every quarter. I know, this is basic finance, right? But it tells you how to structure your innovation. Don't put everything on red 44, right? Make sure you have a structure in your innovation cycle that gives you information, feedback, content of roughly 30% per quarter. That's a better strategy. So there are lots of other ways to fail. The worst one is probably the not invented here model, right? You've never seen this before, right? Lots of good ideas come from everywhere. For example, this is several years ago now, but we saw another company putting up poison control information. It was like, oh yeah, that's a really good idea. So we did it too, right? Innovation can come from everywhere, including your competition. Including things like, why should we rewrite all of the medical history textbooks rather than just pulling this information out from the National Library of Medicine, right? So we need to deal with them. If you type in a medical condition, we will just give you the best, most authoritative information we can. Again, leveraging others. Don't get stuck behind not invented here. And that, surprisingly, hangs up a large number of projects, the not invented here syndrome. And it's really subtle, because the manager says, yeah, I just don't like it. I don't think it's going to work. And it's really a hidden manifestation of the not invented here parasite. Same thing with doing people finder after major disasters. So You also want to set up, in part of your culture, a place where innovation can happen, where invention can be just thought of, right? So 20% time I mentioned is 1 day a week where you get to do this. Now, let me tell you a trick. Part of the trick here is that think about all of this presentation as kind of the set of culture hacks that we use at Google. Here's a great culture hack, 20% time, awesome. Better culture hack. I can't do much on 20% time, but if I could find 5 of my friends, I have 1 full-time equivalent. So if you're really sharp, what you'll do is you'll find a bunch of friends, you'll find some desks and push them together, and every Friday we have our own startup. A 5-person startup for 1 day a week, but that's 1 full-time person. That's the way Google News started. Krishna Bharat was having trouble finding all these aggregated news sources, so he just spent a couple days and built the first version of Google News. Right? It's a 20% project that is now a major force in the news industry. So these things can have massive output. Another important part of the Google cultural structure is that we have a lot of cross-functional collaboration methods that are sort of baked into our system. For example, we have these things called intergrouplets. Fancy name for, I'm going to form a little group and you're over there. We're going to basically make these cross-product areas groups that fix a particular problem. There are a lot of examples for particular things like authentication issues. You can't solve it within a single product. You have to go necessarily across products. So you form these intergrouplets in order to solve and deal with all those problems. We also have things called fix-it days, where you get 100 people and everybody stops what they're doing, and for 8 hours you just fix bugs, or you fix documentation, or you clean up the code, or you remove technical debt, or whatever it is. Focused time beats unfocused time every day. So declaring a fix-it on Friday is just one really effective way to do that. Like hospitals, we also have codes, right? So we don't have code blue, but we have things like code red or code yellow, where we declare, or usually an exec declares, there's a major problem with product X, we need to fix it now. Everybody stop what you're doing within that product group and just work on this one problem. So it's a way to focus everybody who's normally just building stuff and keeping it all moving along. Stop all that, suspend it, focus only on this, get it done, and then you can go back to that. Code red means everybody else drops, you stop going home, you stop doing everything, right? You just get that until it's done. And finally, there's this sort of idea about supporting the adjacent possible. These are the folks that are in the building or the cube next to you that are doing something similar that if only they knew what you knew, their job would be so much better. And so we do a lot of that kind of thing. So TGIF is a weekly meeting where, traditionally on Friday, but now on Thursday for reasons that are obscure. But it's product announcements and it's presentations by teams that tell you what my product is doing. And afterwards, you can go up to them and say, hey, my product has that same problem. So it's explicit sharing cross-company, right? We also have lots of internal talks. A lot of graduate students, when they come to Google, one of their first comments, and I've heard this many, many times, is, this is more like universities than the university. And frequently what they mean by that is that there are so many talks that if you go to half of the talks, you don't have a job. You just will go to nothing but talks. So for example, this morning I got out the list of talks going on today at Google, and there were about 24, just today. So a lot of them overlap. So that's another way of doing internal dissemination. And another fact that has caused a lot of controversy is we don't have too many distributed sites. We only have engineering in a very small number of sites. It's not, we used to have like 20 different sites, and now we only have like maybe 6 or 7. It was too hard to communicate cross space. Yes, we got great video conferencing. It's awesome. It's wonderful. It doesn't substitute for being there in person. Another big lesson we've learned is being good with acquisition. One way to innovate is to buy. Now, if you've got a lot of money in the bank, that's great. So for us, buying a company like Deja or Pyra or Urchin or Keyhole, Keyhole was the predecessor to Google Earth, was a great way for us to bootstrap that whole effort. Now, I will tell you, not all of our acquisitions have worked out equally well. Acquiring a company, integrating the people and the technology is hard. but we're getting better at it. It's one of these things. This is a famous disaster of engineering where we try not to have that happen. But I love the illustration. This is the Tacoma Narrows Bridge. What's interesting about it is that the bridge people, that is the civil engineers, have historically had a culture where they analyzed that kind of that failure to death. And they've done this for years and years and years. So they've got this huge body of knowledge about how to not design bridges. Do we do something similar for software engineering? Well, what we do. At Google, when something goes wrong, there's almost always a post-mortem analysis, which then produces either a presentation or a document saying what happened. So there's a lot of stories I could tell you, but those post-mortems are, yeah, good on you, right? They're supported, and yes, you shouldn't have all of Google fail again. That's a bad thing. But now, not only do you know what the problem was, but now everybody else does. Classic example was somebody had a missing asterisk in a configuration file and brought down all of Google globally. It was a huge problem. And we got it fixed fairly quickly, so we hope nobody noticed. But there was a postmortem about that, and so now config files, which, you know, it's just a config file. How can you screw it up? Well, you can screw up everything. So now they've got their whole own validation process, so they get tested before they're launched as well. The product I worked on was Google Notebook, which was kind of, think of it as kind of like Google Docs, except it was tightly integrated in with the search page. It was awesome, or at least I thought it was cool. We worked on this for a couple of years. We launched it. It actually ran for about 5 years, and then it was de-launched again because it had no growth curve. We had a couple million users, and I know that sounds like a lot, but for Google, that's not a big enough number. And the growth, there was not sufficient growth to maintain it. So we de-launched it. But a good idea can never be suppressed. So 2 years ago, we launched Google Keep, which is a version of Google Notebook, but they did the smart thing, which is they make it run on your laptop and your phone, and they're integrated. So they did a really beautiful integration, and they stripped out 90% of the cool functions that we were so proud of. We built Google Notebook, awesome tool, too much awesome tool, right? And so Google Keep is very dead simple, probably the right choice. So on this idea of being playful, Google Doodles, which are like that, are these very playful things we put out. You've probably seen them, right? For every major holiday. What you might not know is that there are Google Doodles internationally. So the doodles you see here in the US are probably 1/10 of all the doodles we actually launch. So famous writer's birthday in Poland, there's a doodle for that. Boys' Day in Japan, there's a doodle for that. You know, so we do a lot of these kinds of things. You know, Chinese New Year's, several doodles for that. We also try to make our spaces very playful. You know, it sounds silly, but if you don't have a place to play, you don't have a playful mind. And so we do a lot with our spaces, like with the bean bags and so on. I didn't have a picture here. It says in my notes, add a picture of a Googler sleeping in a quiet room or sleep pod. Yeah, it's the first place I've ever worked where it's okay to go to sleep. And there's a sofa near where I sit, and I would say 2 or 3 times a week I see somebody sleeping there at 3 in the afternoon. There's a nice warm fuzzy blanket there, and they just knock out. And I mean, you know all the science behind that, right? You know, it's a really good thing to do. So we just, you know, we're a data-driven company, right? So there's an example of some of the Google Doodles, Swiss National Day. We did one for the Perseid meteor shower. And this is in my office, actually. We've got a slide like that. Takes you down to the first floor. And I put this here partly because we've got great food. Google's known for that. But I categorize it under the playfulness part because, truthfully, the very first day I went to Google, you get the Noogler introduction. You get to put on the propeller hat with the little beanie. I still have mine. It's great. But we went out into the plaza afterwards, and it was one of those beautiful October days in California where the sun is setting and it's warm, you've got your beer, and we sat and just talked to random people. And all of a sudden, you now have all these friends, right? It's socially engineered. Everybody knows this, but it's designed to support this kind of collaboration and friendship building. We also, though, have a feeding your mind style. So internally, we have Google EDU. And this is a list of some things. There's everything from system profiling and code profiling all the way over to how to cook pasta classes. And so the Google EDU thing does, I forget how many, but it's something like 5 or 6 classes per day year-round across each site. So it's a huge number of classes. Some are technical, some are for fun. It always makes you feel like you're in a vibrant environment. And second, those people who teach the classes are usually experts on that topic. So if you need to find somebody who's expert on C++ code profiling, I know how to find them. So to recap here, right, the idea, the culture of Google is really, it's got this expectation where it can happen, where it's playful and all that. I'm going to leave you with a couple of maxims. You have to have a culture that evolves. You cannot get the culture right with the first shot. Being pragmatic is everything, as is measuring everything. We have a big project called Project Oxygen that measures the internal structure of the organization, how happy people are, how often they've moved, et cetera, et cetera. Staying lightweight so you can restructure as necessary, and what that means is destaffing stuff that doesn't work. Now, I know I said be flexible, be passionate, but I'm also saying de-staff. And the example of Ron with graphing calculator is like, how can you have it both ways? You have to make a judgment call, right? This is what really good management is about, is making those good judgment calls. Because ultimately, you're hacking your own culture. You're hacking your culture in a way to make it deeper, more playful, more innovative, better expression. I'll leave you with this last thought from Chuck Close, who says, and I think he's right, inspiration is for amateurs, right? You can't count on the inspiration striking in the middle of the night. The rest of us just show up and get to work. And that, I think, is ultimately the key to making Google culture work, is that people come in, they have friends, it's a playful environment, but they just sit their rear end in the chair and work. So there's some data for me. Thank you so much for coming. Appreciate it.